Welcome to Chopra School of Physics. And now we are further proceeding after various types of topics we have discussed about permittivities, dielectric constants, electric fields, Lorentz convention. And now we will discuss the application of Coulomb's law, the formula of Coulomb's law, and how we use them in the various numerical problems. So, Coulomb's law states that like charges, like if we take two positive charges, they are quite close to each other, they will repel. So we will write two negative charges, if they are close to each other, they will also repel. But if one is positive charge and other is negative charge, there is tendency of attraction. So now the law is like charges repel and unlike charges attract. Like charges repel and unlike charges attract. Exception is nucleus. We know that nucleus is made up of nucleons, that is protons and neutrons, other than hydrogen nucleus. Now within the nucleus we will remember there are three types of combination among the nucleons. These combinations are called proton-proton combination, the neutron-neutron combination, the proton and neutron combination. So these nucleon pairs are within the nucleus and there are three types of nucleon pairs. So you will now remember that the statement which we have written, like charges repel and unlike charges attract, this statement is not valid to nucleus. Now why? Nucleus is made up of nucleons. When we use this term nucleons, they are protons and neutrons. And protons and neutrons, when we speak other than hydrogen nucleus, because hydrogen nucleus is simply made up of proton. So there is no question of grouping here. Within the nucleus, the nucleon groups are pp and n, pn. These are called the nucleon pairs. Nucleon pairs. You will also remember that these all nucleon pairs, they constitute a nucleus. And the size of nucleus, that is the radius, is very, very small. Order of nuclear radius 10 to the power minus 15 meters. Maximum 10 to the power minus 14 meters. Or it is 10 to the power minus 13 centimeters to 10 to the power minus 12 centimeters. So these all nucleons are packed in this particular size. They are very close. Within the nucleus, from many experiments, we have confirmed that two protons within the nucleus have tendency of attraction as well as tendency of repulsion. However, they have positive charges. According to this law, like charges repel and unlike charges attract. These two proton pairs must repel, but they are not repelling. Sometimes they are repelling and sometimes they are attracting also. Similarly, neutrons, they have no charge. So sometimes they attract and sometimes they repel. Similarly, protons have positive charge, neutrons have zero charge, still they are attracting or repelling. Therefore, the forces among the nucleons, forces among nucleons are nuclear forces. Nuclear forces. So which type of forces are there? Nuclear forces. But these forces are electrical forces. Like charges repel, unlike attract, these repulsive or attractive forces are electrical forces. Electrical forces. Nuclear forces do not obey Coulomb's law, but electrical forces obey Coulomb's law. They are called electrical forces obeying Coulomb's law. Coulomb's law of electrical forces. But these nuclear forces, they are charge independent forces. They do not depend upon charge. So we will say nuclear forces, charge independent forces, charge independent forces, but distance dependent forces. Distance dependent forces. So they are charge independent forces but distance dependent forces. If D is greater than equal to 0.5 Fermi, nuclear forces will be attractive. If D is less than equal to 0.5 Fermi, this is distance greater than equal to 0.5 Fermi up to 3.8 Fermi. But if it is less than equal to 0.5 Fermi, nuclear forces will be repulsive. If D is greater than equal to 4 Fermi, the nuclear forces vanish. Therefore, range of nuclear force is nearly 1 Fermi to 4 Fermi. We have taken an approximation. 0.5 Fermi taken as 1 Fermi, 3.8 Fermi taken as 4 Fermi. So range of nuclear forces 1 Fermi to 4 Fermi, and we will say nuclear forces are short range forces. Short range forces. So they do not obey Coulomb's law. Nuclear forces do not obey Coulomb's law. So the point is here, a question is there that like charges repel, unlike charges attract. This is called the statement of the Coulomb's law, and these forces are called the electrical forces. They are obeying the Coulomb's law, but nucleus, which is made up of nucleons other than hydrogen nucleus, there are three types of combinations: proton-proton combination, neutron-neutron combination, proton-neutron combination. That is nucleon pair combinations. The order of nuclear radius I have already written here, and forces among the nucleons, they are called nuclear forces. Nuclear forces are charge independent, they do not depend upon charge, but they are distance dependent forces. And this is the range: D greater than equal to 0.5 Fermi up to 3.8 Fermi, they will be attractive. Less than equal to 0.5 Fermi, they will be repulsive. And if nuclear forces exceed 4 Fermi, then nuclear forces will vanish. So range of the nuclear forces, they are valid from 1 Fermi to 4 Fermi. So we can just understand like this, that if many students are very close to each other in a summer season or in a hot season, then all the students try to push each other. So it means very closely they start pushing, repelling. But if they are slightly away, it's a winter season, they say come close. So they begin to come close. This is the logic. So here we will find that very close if they are, repulsion. If they are slightly at a distance apart, they will attract, and there is a range, 4 Fermi. There will be no nuclear force. So I hope that this is a physical phenomenon of the Coulomb's law, and mathematically we will discuss later on. So I think that this particular concept is clear to you. Thank you very much.